Hello everyone. So in this video we will calculate input impedance of a cross coupled source degenerated MOSFET circuit. Okay. So first we will solve without RS, and then after analyzing without degeneration we will come back to the degenerated. Okay. So for that I have copied the same circuit without RS. Okay. So let's calculate input impedance of this circuit. So for that we will apply a test voltage here. So I am applying this test voltage of polarity, this one, plus minus. Okay. So and this will be small signal ground. So suppose I am assuming this node voltage is V1 and this one is V2. Okay. So the gate voltage of M2 will be this one V1, and gate voltage of M1 will be this V2. So what will be the this current? This current will be GM2 VGS2. So that will be equal to the GM2, and what is the gate voltage of M2? That is V1, and source voltage is 0. Similarly, this will be GM1 VGS1 equal to GM1, and VG1 is V2. So that will be GM1 V2. Now this current and this current will be equal and opposite. Okay, so we can write a GM1 V2 equal to minus GM2 V1. Now what will be the VT? VT will be V1 minus V2. Okay, and this will be V1, and put V2 in terms of V1. So that will be 1 minus, this will be minus of GM2 divided by GM1 into V1. Okay, so I will take V1 common. So V1 1 plus GM2 divided by GM1. So this is equation 1. Now we will see IT. So IT will be, IT is nothing but this current GM1 V2, or it's a minus of minus GM2 V1. Okay. So IT will be GM1 V2 equal to minus GM2 V1. Okay. I am calling this equation 2. So for calculating input impedance, we will take ratio of both. So that will be VT by IT. So VT is 1 plus GM2 by GM1 into V1, and IT I will take this one to cancel out V1. Okay, so this will be GM2 minus GM2 into V1. So this will cancel out, and I will take minus sign outside, and I will divide GM2 inside. So that will be 1 by GM2 plus 1 by GM1. Okay, so we can write again Zin equal to minus 1 by GM1 plus 1 by GM2. So this is our input impedance. Okay, if we assume GM1 equal to GM2 equal to GM, then it will be Zin equal to minus of 2 times 1 by GM. Okay, so now we got our answer as Zin equal to minus 2 by GM. Okay, so we already know, we had a kind of intuition like that this is kind of a diode connected device, and we know that for a diode connected we will get 1 by GM, and both are in series, so that will come as 2 by GM, but we are getting a negative sign. So for that we will analyze further why we are getting that negative sign. Okay, so for that let me copy that circuit again. So now let me erase this one. Now this one is source voltage, both are equal, okay, equal to 0, or you can assume anything, okay, both are equal. And this one is drain voltage of M2, okay, and this one is VDS2, and this one is VG1, and this one is VG2, and this one is VDS1, and this one is VD1, okay. Now what will be the VGS1? VGS1 is VG1 minus VS1, and VG1 is this VG2, okay. So that is VG2. And what is VS1? VS1 equal to VS2, so that will be VDS2. So this will come as VDS2, okay. This already we can see the in this loop, okay. If we move around this loop, so we can see that VDS2 equal to VGS1, okay. So let me call this as equation 1. Now what will be the VGS2? VGS2 will be VG2 minus VS2, so that will be VG2 equal to VD1 and VS2 equal to VS1, okay. So now this will be VDS1. So again this is also like visible in this loop, okay. If we will move in this circuit, so we will get VGS2 equal to VDS1, okay. Now we know that both current are equal and opposite, okay. So GM1 VGS1 equal to minus of GM2 VGS2, okay. So if I assume GM1 equal to GM2, okay, equal to GM, so what will be the this equation? This will give a GM equal, I will take outside, and that will be VGS1 plus VGS2 equal to 0. From here we get VGS1 equal to minus of VGS2, okay. So this is our third equation. Now we got three equations: VGS1 equal to VDS2, VGS2 equal to VDS1, and VGS1 equal to minus VGS2. This all three are visible. When we move around this loop, we will get VDS2 equal to VGS1. When we will move around this loop, okay, so we will get our VDS1 equal to VGS2, and we will move this loop, so we will get VGS1 equal to minus VGS2, okay. Now we will use this equation to come up an interesting result, okay. Now from equation 1 and 3, okay, so minus VGS2 equal to VGS1 equal to VDS2, okay. From 3 we know that VGS1 equal to minus VGS2, so I write the same, okay. This one is VGS1, and from 1 I know that VGS1 equal to VDS2, okay, so I write the same. Now from here, what will be the VG2? If I take this 2, so source voltage is like in both sides, okay, so that will be cancel out. So from here we get VG2 equal to minus of VD2, okay. So this is an important result. Now again we will use equation 2 and 3, okay. So from equation 2 we know that VGS2 equal to VDS1, and this VGS2 equal to minus of VGS1, okay. So we will again compare these results, so we will get VGS1 equal to minus VGS equal to minus of VDS1. If I take these two, so again I will get VG equal to minus VD1. So we get this VG2 equal to minus of VD2 and VG1 equal to minus of VD1. So what this is representing? This is representing this we are connecting diode connected, but gate voltage receiving a minus of drain voltage. Okay, so if I model this as diode connected, so in normal condition we get this one. Okay, diode connected, but in this configuration we are getting a negative feedback between our this drain and gains. Okay, so that's how we are getting of minus 1 by gm. Okay, so this is drain feedback, and this is our we can call it as like a negative drain feedback. Okay, now like it's clear that why we are getting minus 1 sign, minus 1. Okay, now we know that if any dependent current source is there and its current value depend on the voltage across itself. Okay, like suppose I have this current of gm vgs. Okay, and this is vds. So and suppose I am like taking as diode connected, so in that case vg equal to vd. Okay, so that will be gm VDS. Okay, okay, because VG equal to VD in diode connectors. This is like this case. Okay, and if I calculate Z in this case, so what will be the Z in? That will be VDS by IDS. So VDS is GM VDS, GM VGS or GM VDS, both are same, and IDS will be, okay, this is VDS and this is GM VDS. So this will cancel out and we will get 1 by gm. But what happening in this this diagram? Okay, so in this diagram this is gm vgs. Okay, and this one is vds, but in this configuration vg is minus vd, so this is minus of gm vds. So when we will calculate z in for this case, we will get vds by IDS, and this is minus of VDS divided by minus of GM VDS. So VDS will cancel out and this will come as minus 1 by GM. Okay, so whenever there is a dependent current source and which current is depending upon voltage across itself only, so that will behave as a resistance. Okay, so now we know that why that this minus sign is coming, because of there is a negative feedback from drain to gate. Okay, so if I want to draw that circuit in simplified way, so I can draw as like this. This is my M1 transistor and there is a feedback from drain to gate, that is negative feedback. Okay, and this one will be my M2. Now clearly we can see that if we will look in from that, so this will be minus 1 by gm plus minus 1 by gm, and that will be minus of 2 by GM. Okay, so this is like one important thing. Okay, so we can this is look like complicated, like coupled. Now we can easily make like this diagram, decoupled circuit, and we can apply now a half circuit. So how to use that half circuit? So now again we will come to our original question. Okay, so our main question is this one. So this will be analog ground small signal. So now I can apply a half circuit analysis. Okay, or I can simply remove this connection and I can use this one. This one minus negative feedback. Now you tell me that what will be the input impedance? It will be simply minus of 1 by Gm plus Rs. Okay. So whatever you will see from this side, that will group together. Okay. So that will be again minus of 1 by Gm plus Rs. So that will be as minus 2 by Gm plus 2Rs. Okay, and don't do that like minus 1 by Gm and plus Rs. Okay, that will come inside this one minus and everything whatever you see here. Okay, so that will be grouped together. And from half circuit analysis, that will be Zin equal to minus of 2 times and simply 1 by Gm plus Rs. So that will be minus of 1 plus Gm Rs by Gm. Now suppose there is a capacitance. Okay, so you will get some more circuit like this. Suppose I am assuming some more example. So how you will apply a half circuit here? You just do Zin equal to minus at 2 times 1 by Gm. Suppose this is Z, so that will be Z by 2. Okay. Now instead there is a capacitance. So I am taking the example here that Z equal to 1 by SC. So what will be the input impedance? That will be minus of 2 by 2 into 1 by Gm plus 1 upon S into 2C. When you will do Z by 2, so that will be 1 by 2 SC. So that I have written. So you can show that like this one. 1 by this one behave like 2C. Okay. 2C in series will be C. So this is how we can solve our circuit. So again for summary we can assume like this one. Okay, so there is a negative feedback from gate to drain to gate, and because of that we are getting minus 1 by GM, and here we can apply half circuit analysis, okay, after decoupling this both connection. So okay, so please let me know if there is any wrong analysis or there is any doubt. So okay, bye, thank you.